Hello everyone, I hope you're doing well. So in this video, we're going to discuss Leetcode problem of the day, and today's problem is perfect squares and it is a medium level problem. So the problem basically says that we have been given an integer n, we have to return the least number of perfect square numbers that sum up to n. Right, now we can solve this problem in many different ways, but I'm going to discuss a very interesting way. This problem is a very good example of how sometimes a problem you might seem to encounter for the first time can be reduced to a problem that you must have already solved before, right? So you must have solved this particular problem, which is known as coin change, right? This is a very popular problem. When you first study DP, you generally solve this particular problem, coin change. So what is the premise of the coin change problem? The problem basically says that you have been given certain coins of different denominations and you have been given a target sum, right? This is the basic premise. Now the problem might ask you to find anything related to these things, right? The problem might ask you what are the different number of ways to make the target sum, what is the minimum number of coins to make the target sum, and any other thing like this, right? So this problem is also a very similar problem. If you carefully see, the value of n, or the value of maximum sum here, is up to 10 to the power 4, right? Like this. So what is the maximum value for which the square is less than or equals to 10 to the power 4? Because we are asked to take square values, right? Perfect square values, right? So one square will be equals to 1, 2 square will be equals to 4, 3 square will be equals to 9, right? Why am I writing these three values? Because these values are perfect squares, right? 1, 4, 9, and the next value will be 16. 4 square 16, right? So the maximum perfect square that I can take is 10 to the power 4, and that is 100 square. So in fact, if you see, I clearly have only 100 unique values to take, right? It can be 1 square, 2 square, 3 square, 4 square, and up to 100 square. So basically, if I reduce it to the original problem, then it says that we have been given 100 different values. All of them are from 1 to 100 square, right? 1 square, 2 square, and so on up to 100 square. These are the different values that I have been given, and I have also been given a target sum, which is n. So I want to find out the minimum number of coins or the minimum number of values I need to pick from this particular range to make this particular target sum, right? This is our whole problem now. So this problem can be solved with DP. Now what I am going to do is I am going to create a double dimensional DP of in, where let's say DP of ij, I is going to denote the current value and j is going to denote the sum left, and dp of ij together is going to denote the minimum number of values to be taken to make sum j with values from I to 100, right? That basically means if you are a DP of ij, it is going to store the minimum number of values to be taken to make the sum j with the values from I to 100, right? You can take all the values in the range from I to 100. So how can we actually solve this problem? Let us just first write the base case. So base case is going to be dp of I 0 equals to 0, because if j is denoting the remaining sum, then whenever your remaining sum is 0, that basically means you have found a valid configuration and you need no more number of coins, right? This is for sure. Now let us just write the helper function, helper int I int j. So I'm just going to write the recursive or the memorize function. So if j is equals to 0, I'm just going to return 0. Now if I is equals to 101, that basically means if my j was not equals to 0, that means this condition was not triggered, but this condition was triggered. That means I have exhausted all the different kind of values. Then I can never form my answer, so I can return infinity from here or a very large value. which will show that the answer is not possible from here. Now, if dp of ij is not equals to -1, that means I have already computed this part, then I'm just going to return dp of ij, return dp of ij. Now what I'm going to do, I have two choices. Either I can take, so let me initialize this with infinity, or I can not take this particular value. Both of them are initialized with infinity. Now no take is simple. I just go to dp of I plus 1, that means, or let me write helper of I plus 1 and j. So you see, when I decide not to take the current coin, then I move on to the next value or the next possible value, and j will remain as it is. I can try to take the current value, but I can take only if j into j is less than equals to I, right? So I can only take it, sorry, I into I is less than equals to j, because I is the current value and j is the remaining sum, right? Because I can only take the current value if it does not exceed the current remaining sum. So take will be equals to 1. 1 is for the current value that I have taken, plus helper of I will remain as it is, but j will get subtracted by I into I. So you see what is happening here. I added one more operation because I have taken one value. I will remain as it is because in the next move also I might want to take the I value. Now j will get decremented because I have taken a value I have to subtract its square from here, right? So j minus I into I. Now I'm just going to return dp of ij as minimum of take comma no take. So you see, this is how you can solve this particular problem. Let me just quickly go through what I have just written here. First of all, the very first thing I do is, if j is equals to 0, that means my remaining sum is 0. That means I have found a valid configuration, and here I can return the number of remaining steps are 0. If I is equals to 101, that means I have not found a valid configuration, but I have exhausted all the different values. Then I have to return infinity to denote that a value is not possible from here. Now if dp of ij is not equals to -1, that basically means I have already computed this value and I don't want to compute this again, so I return the saved value. Now if I just have this take and no take value, so take is equals to infinity, no take is equals to infinity, that means they are going to represent what happens, what are the number of operations or what are the number of values if I decide to take the current value and if I decide not to take the current value. So if I decide not to take, my helper is going to I plus 1 to denote the next possible value to be taken, and the sum will remain as it is. Now if I take the current value, I can only take it if the value that I am taking, that is I into I. Here you can see that I am only dealing through values from 1 to 100, but I needed perfect square, so I am going to calculate their square. So if I into I is less than equals to j, I am going to take the current value, that will take one number of operation, and the remaining answer will be from helper of I, j minus I into I. So this particular new I remains the same because I might want to take the same value again, right? Now what I do is I just return dp of ij as minimum of take comma no take. So this is the final solution. Now let me show you my code which is written in iterative dp. So here what I have done is I've initialized the value of infinity to be 10 to the power 9. Why 10 to the power 9 specifically? Because if you can see, for value of n 10 to the power 4, the answer will be 100, right? And no matter what value you take, if you take 1111, the maximum value will be n itself. So the maximum value of n is 10 to the power 4. There can never be an answer greater than 10 to the power 4, right? Even 10 to the power 4 is not possible, I believe. Now I just created dp vector. I've initialized it with 102 just to take some extra spaces, and the second part is n plus 1. Now I'm just going through all the values of I and marking dp of I 0 as 0. This is my base case where if the sum becomes 0, my answer is going to be 0. You can ignore these two for loops for now, we will come to it later. I've initialized this take and no take with infinity. I mark my no take as dp of I plus 1 j, and if my I into I is less than equals to j, I am just going to mark my take as 1 plus dp of I j minus I into I, and then set dp of ij as minimum of take comma no take. You can clearly see that it is very similar to the recursive function. The only difference is this helper function has been replaced by dp array or vector. Now if we discuss these for loops, you can clearly see at certain stages uh, my dp of ij is depending upon dp of I plus 1 j, right, where j remains as it is but I increases, whereas in certain stages my dp of ij is depending upon dp of I and j minus something, right? So let us first talk about this one. This basically implies that I plus 1 has to be computed before computing I, right? Because dp of I is depending upon dp of I plus 1. So that is why my first for loop is in reverse order. Now here when we come, we see that for the same I, because dp of ij is depending upon dp of I comma j minus something. For the same I, j is depending upon some value less than j, right? Because we are subtracting something from j. That is why this particular for loop will have to be computed in forward order. If you do the second for loop in reverse order as well, it will not work. These are the small things that you have to take care of while writing the iterative code, right? And this is how you can quickly verify whether your for loops are correct or not. So for the same I, my j minus something has to be computed before computing j, so that is why this is in forward order. Now at the end, I can just return dp of 0n. So what does this signify? This basically means that my current value is 0 and my remaining sum is n. Find me the best answer from here on, right? So that is why this is going to be my final answer. So let me quickly submit this and show you that this particular code works and this solution is absolutely correct. So you see this passes all the test cases and the solution is correct. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video and don't forget to share thoughts in the comments, because your engagement with this video really helps the YouTube algorithm to understand that this video is actually helpful for you and it will be able to reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.